Welcome to class 7 mathematics classes. Today we are going to start a new chapter, probability, a short chapter but an important chapter. So here, probability is a branch of statistics which deals with the numerical measurement of the degree of certainty of the occurrence of an event. So here we understand probability is the branch of statistics and it deals with the numerical measurement of the degree of certainty, means of the possibilities of the occurrence of an event. So of any event, the possibilities of occurrence is determined by the probability, okay, by the method described in the chapter probability. Okay, so here few terms related to probability like experiment, random experiment, trial, event we need to understand. And in our daily life, we come across statements like there are chances that the train will arrive late, he will probably meet me on Monday, it is likely that Raman will come home this month, you can possibly solve this problem. So here, chances, probably, likely, possibly convey the same meaning. That is, there is uncertainty, okay, in the happening of the event. So in other words, these terms show the probability of occurrence of the event. This branch of mathematics started with the gambling and game of chance. It is now used extensively in science, commerce, biological sciences, weather forecast, etc. So experiment is an operation which can produce some well-defined outcomes, okay? Like when we roll a die, okay? Here the outcomes we know, that is 1, 2, 3, 4, 5 and 6, okay? So these are well defined, outcomes are well defined, okay? So this is an experiment or an operation where we know the outcomes in advance. But random experiment is an experiment in which all outcomes are known, but what exact outcome is going to come we don't know, okay, we cannot predict it. So this is a random experiment. In the case of a coin, there are two outcomes, head and tail, okay? So while tossing it, we don't know what outcomes will come. So this is a random experiment. So while performing a random experiment, we call it as a trial, okay? And occurrence of the outcome is the event, okay? In the case of 52 cards, when we draw a card, any card, then the occurrence of the outcome is an event, okay? And drawing the card is the trial, okay? So performing this experiment is the random experiment, okay? We need to know one formula, that is empirical probability. So here P stands for probability, E stands for event. PE is given by number of trials in which event E occurs by total number of trials. So this we will use in our exercises, okay? Question number 1. When a coin was tossed 200 times, we obtained head 118 times and tail 82 times. When the coin is tossed at random, what is the probability of getting a head and a tail, okay? So given here is total number of trials, that is 200 times. Solution, total number of trials is equals to 200, number of heads, okay, obtained is equals to 118 times number of heads obtained is equals to 118 times, and number of tails obtained 82 times. Okay, now probability of getting a head is given by the empirical probability. So number 1, probability of getting a head is given by number of heads in these trials by total number of trials. So number of heads in these trials is 118 times and total number of trials is equals to 200 times. So here 118 by 200 times, which we can cancel by 2. So the probability of getting head is 59 by 100. Okay, so now question number 2, that is this one, a tail. Probability of getting a tail, probability of getting a tail is given by number of tail in these trials by total number of trials. So number of tails in these trials is 82 times and total number of trials is 200 times. So here 82 by 200, this can be cancelled by 2. So here 41 by 100 is the probability of getting tail. Okay, question number 2, a die is rolled 150 times and the outcomes are noted, which are tabulated as shown below. Outcome are 1, 2, 3, 4, 5, 6 and frequency of outcomes are given here: 29, 17, 24, 19, 33, 28, which means outcome 1 appears 29 times. Okay, outcome 2 is obtained 17 times, like that. 3 24 times, 4 19 times, 5 33 times, 6 28 times obtained. When a die is rolled at random, find the probability of getting 1, 4 and 5. So here given is total number of trials 150 times, and 129 times, 4 19 times and 5 33 times. Okay, so we have to find probability of getting 1, 4 and 5. So number 1, probability of getting 1 is given by the total number of times 1 obtained, that is 29, by total number of trials, that is 150. So this is the probability of getting 1. Number 2, probability of getting 4 is given by number of times 4 obtained, that is 19, and total number of trials 150. Similarly, 3 number, probability of getting 5 is given by number of times 5 obtained, that is 33, divided by total number of trials, that is 150. So this can be cancelled by 3. So 11 by 50 is the probability of getting 5. 3 number, 5 cards numbered 1 to 5 are placed in a bag. A card is drawn from the bag 30 times. So 5 cards are there in a bag and card is drawn. from the back 30 times. That is, total number trials is equals to 30 times. Each time the number on the drawn card is noted and the card drawn is replaced. The outcomes are tabulated as shown below. Outcome 1, 2, 3, 4, 5. Okay, frequency 4, 10, 7, 5, 4, which means outcome 1 appears 4 times, outcome 2 obtained 10 times, outcome 3 obtained 7 times, like that, 4 5 times, and 5 4 times. If a card is now drawn at random, find the probability that the card drawn bears the number 2, 3, and 5. So we have to find the probability of getting 2 and probability of getting 3 and probability of getting 5. So total number of trials is equals to 30 here. So that we will write here. Now probability of getting 2 is given by 2. Okay, so here 2 is obtained 10 times, isn't it? So here 10 by 30, total number of trials. Okay, so here 0 0 cancel, probability of getting 2 is 1 by 3. So similarly 2 number, probability of getting 3 is given by total number of outcomes, that is 7, and number of trials 30. Okay, now 3 number, probability of getting 5 is given by 4, that is the number of times 5 obtained, and total number of trials, that is 30. So we can cancel this by 2. So here probability of getting 2 is equals to 1 by 3. Probability of getting 3 is 3 by 30, 7 by 30. Probability of getting 5 is equals to 2 by 15. Okay. Question number 4. 2 coins are tossed simultaneously 100 times. We obtain 2 heads 23 times, 1 head 56 times, 0 head 21 times. When 2 coins are tossed at random, what is the probability of getting number 1 2 heads, number 2 1 head, number 3 0 head? So here head is this one. Okay, this is the head and this is the tail, okay, of a coin. So here number 2, total number of 1 head obtained is equals to 56 times. Okay, so here 56, and probability of getting 1 head is given by total number of 1 head obtained, that is 56, and total number of trials, that is 100. This can be cancelled by 2. Again it can be cancelled by 2 only. So probability is 14 by 25. Okay. Number 3. Total 0 head obtained is equals to 21 times. Okay, now probability of getting zero head is given by total zero head obtained, that is 21, by number of trials 100. So the probability is 21 by 100. Okay. 5 number, in a survey of 200 employees of a company, it was found that 89 liked the lunch packs provided by the company while the rest did not. Out of these employees, if one employee is chosen at random, what is the probability that the chosen employee, number 1, likes the lunch pack, number 2, dislikes the lunch pack? So here number of trials is equals to 200, that is the number of employees only, and total number of liked is 89, and total number of liked will be given by 200 minus 89. So solution, given total number of employees is equals to 200, therefore total number of trials will also be equal to 200. Number of people liked is equals to 89, and number of people disliked is equals to 200 minus 89, that is 111. Okay, so we have to find probability of likes the lunch pack and probability of dislikes the lunch pack. Okay, so here we can, number 1, probability of likes the lunch pack is given by the total number of likes, that is 89, by total number of employees or trials, so it is 89 by 200. Similarly, number 2, probability of dislikes the lunch pack is given by total number of dislike, that is 111, by total number of trials or employee, that is 200. So this is the probability of dislike and this is the probability of likes. Thank you very much.